In today's lesson, we're going to remind ourselves about Pythagoras' theorem. It's important to remember that Pythagoras' theorem only works in right-angled triangles. In the triangle that you can see on screen, we've labelled the sides A, B and C. Pythagoras' theorem says that a squared plus b squared is always equal to c squared, where c is the hypotenuse. The hypotenuse is simply the longest side, and it's always opposite the right angle in your triangle. Now I'm going to have to rearrange this formula depending on which side I'm trying to find, whether it's A, B or C. Let's have a look at how we'd do this. If I wanted to find my longest side C, I can start off by switching the formula around and saying that c squared is equal to a squared plus b squared. From here, because I want to know what c is, I need to square root both sides. So c is equal to the square root of a squared plus b squared. If I wanted to calculate one of my shorter sides, let's start off with a for example, I'd begin with the initial formula, which is a squared plus b squared being equal to c squared, and because I'm trying to find a, I'd begin by taking b squared from both sides. That would leave me with a squared being equal to c squared take away b squared. As with the previous example, to get a by itself I'm going to need to square root both sides, so I can say that a is equal to the square root of c squared take away b squared. The last rearrangement is for when we want to find the side b. I'm going to start off the same way I did in my previous example, so that's a squared plus b squared is equal to c squared. This time, because I want b on its own, I'm going to subtract a squared from both sides. That leaves me with b squared is equal to c squared take away a squared. And as with the previous examples, to get b by itself I need to square root both sides. So b is equal to the square root of c squared take away a squared. In short, if you're trying to find c, which is the longest side, that's this one here, you simply add the square of the two shorter sides and square root your answer. If you're trying to find one of the shorter sides, either A or B, you square the hypotenuse, which is the longest side, and the other shorter side and find the difference. Once you've done that, you square root your answer. Notice how when we're calculating the shorter side that the hypotenuse squared always comes first in the calculation. This is important because if you do it the other way round, you'll get a negative number, and if you try and square root a negative in your calculator, it will come up with a math error. So let's have a look at some examples of how to calculate the missing sides. In this first triangle, we're asked to find x, which is a length opposite the right angle and is therefore the longest side. That means that I need to square the two shorter sides, add them together and then square root my answer. So I can say that x is equal to 3.8 squared added to 7.3 squared, all square rooted. And I can use my calculator to work out the answer to this. I can start off by pressing my square root button, and I want to do 3.8 squared added to 7.3 squared. When I press equals, I can see that my answer is 8.2 to 1 decimal place. So I can write down x equals 8.2 centimetres rounded to 1 decimal place. In this second example, I'm asked to work out one of the shorter sides. I know that it's a shorter side because 8.9 is my hypotenuse. It's opposite the right angle and therefore the longest length of my triangle. This means to work out x, I need to do 8.9 squared, that's the hypotenuse squared, take away 4.3 squared, and then square root my answer. As with before, I can use my calculator to work this out. I want to start off by pressing the square root symbol. I've got 8.9 squared, take away 4.3 squared. That gives me an answer of 7.8 when I round it to one decimal place. So I can say x is equal to 7.8 centimetres when rounded to one decimal place. Another common example of where Pythagoras is used is finding the distance between 2 points. On our diagram we have A, which is at the point 2, 3, and B, which is at the point 8, 6. We want to find the distance between the 2 points. First of all, we need to recognise that the distance is given by this line just here. We can think about the distance we've moved across and upwards to help form a right angled triangle, which we can use Pythagoras on to find that length. So in terms of my x direction, I've moved across from the point 2 to 8, so that's a distance of 6 in total. In my y direction, I've moved from 3 up to 6, so that's a distance of 3. I can now use Pythagoras to work this out. I know that this length just here is my longest side. That's because this is my right angle that's formed down the bottom here, and it's the side that's opposite the right angle and therefore the hypotenuse of the triangle. Because of this, I can say that AB is equal to 6 squared plus 3 squared, all square rooted. And I can use my calculator to help me work this out. I need to start off by pressing my square root, and I have 6 squared, which is added to 3 squared, converted to a decimal, gives me 6.7 to one decimal place. I can therefore say that AB is equal to 6.7 units to one decimal place. If the question tells us the measure of distance used for each square in our grid, we can specify exactly what the units are. In this case it doesn't, so I've just put 6.7 units. So what I'd like you to do is complete the task that's set on my maths for you on Pythagoras' theorem. You need to remember that the first login is always the school login, and that's Uppingham and Acute, and if you need it, your portal logins are attached to Show My Homework in the Resources to Help You section. You should aim to get at least 70% on this task to demonstrate that you've understood everything. If you'd like to improve your score but it's disappeared from your homework list, you can find it again by using the Results tab on the left hand side when logged into your portal. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.